welcome. Hi, everyone. I hope you're having a good conference so far. Come on in, sit in the front rows because we're going to be showing code. So it's going to be slightly smaller than this. Hi, I'm Daniel. That's what I look like when I speak about Spring Security at DevVox Belgium, and that's what I look like when I speak about Spring Security at DevVox UK. I work at Broadcom in the Spring and Tanzu teams, and in Spring I do everything Spring Security, so Spring Security, Spring Authorization Server, LDAP session, and so on. Here are my socials. Please take note of them. I will give them again. Feel free to reach out. I'm here to meet the community, to get your feedback, to get your questions. And so I always take the time to answer any requests, messages you have for me. So while people are still coming in, setting up, the theme of the conference is fun. And so, ladies and gentlemen, I present to you pain and suffering instead. When we go, we know about this, right? When we go to conferences and we ask questions, yo, do you have a minute to talk about Spring Security? Usually we get reactions a little bit tense, right? What do you think about Spring Security? Oh, it's so complicated. And then I went to Stack Overflow, I copy-pasted this and that, and it just doesn't work. And then I have this old config and I need to change it and I don't remember how it works. Usually we get maximum confusion. So just to get a temperature in the room, first, who uses Spring Boot? Yeah? Who likes using Spring Boot? And most people, right? Who uses Spring Security? Most people. Who likes using Spring Security? One hand, 2, 3, 4, 5, 6, 7. Well, and then half a hand. That counts. Right, so in our docs, we have this thing. Come on, join us. It'll be fun. We have this thing where we say security is complicated. You kind of have to understand the technology before being able to use it and put it in practice. And the same goes for Spring Security. Actually, it's not that complicated, as in there are a few key concepts that once you understand them, understanding the rest of the library is much easier. And that's my goal today. I don't want to give you a demo of all the things that Spring Security can do out of the box and the cool security stuff. I want to give you the keys so you can go and understand by yourself how it works. So when you have your own use case, you don't go to the cycle of pain and suffering on Stack Overflow, copy-paste doesn't work, copy-paste again, and so on. And hopefully, at the end of the session, you have a different opinion on Spring Security, and you come to me like this. Hopefully, we'll see. So there's a lot to cover. The first time I did this session, I did it in 3 hours. So obviously, we won't have time for that. So we'll focus on a few things in Spring Security, and the rest will be left to you as an exercise. So first, we're going to cover Spring Security for Web MVC, Servlet architecture, right? Not reactive. The concepts I show you kind of transpose in reactive nicely. So if you understand what I show you today, you should be able to understand how reactive works as well. Just add mono everywhere, and you should be fine. We're going to focus, so Spring Security does exploit protection. It does a authentication, so knowing who the user is. And then authorization, is the user allowed to perform this action? And we're going to talk a little bit about exploit protection. We're going to focus a lot on authentication, and we won't go over authorization much. Authorization comes after authentication. We need to know who you are before deciding what you're allowed to do. And I like to start with a demo, usually that gives you a baseline. I like starting from scratch, but since we only have 50 minutes, I'm going to show you the built thing. So the idea, again, is not to show you what Spring Security can do, but to have a base application that we can start looking at and improving with Spring Security while exploring the concepts. So we have a demo. I think it's running. It's running here. Perfect. And it's a basic Spring Boot app. It has a public page. When I try and go to the private page, I get this login screen. If you've ever used Spring Security, you've seen this form, right? So I can log in with a username and a password. If I get the password right. Yes. So when I log in, it says, hey, this is the VIP section. Hello, user. And I also enable logging in with a Google identity provider, so I can use my corporate email account to log into Google. And then once I'm logged into Google, then I get logged back into my app using OpenID Connect and Auth 2. Right? So verify this. Yes, it's me, I swear. Passkeys. Hello, Deepu. right? So I logged into Google, and then once I'm logged into Google, my app gets a token, and on the private page, hello, and here's my work account, and that's it. So fairly bare bones app. To make this work, basically, it's not super interesting showing you how it's all built because it's all in like getting started guides. So in 15 minutes, you can build the form login, and in 15 more minutes, you can add Google. So basically, we have an application. It's a Spring Boot app. There's a controller. So the controller here has a public page, and the private page gets this authentication object from which I can derive the email if I use Google, or just the name if I use username and password. And then it has this security config here to configure security for my app. So I just hardcode the user, and then I configure the app. You used to configure Spring Security by doing extend web security configure adapter. That doesn't exist anymore. Forget that. Now, what you do is you provide a bean of type security filter chain. Remember that name. We're going to talk about it in a minute. It takes a builder object, and this builder, you can tell it how you want your security configured. So in here, we say which endpoints we want to protect and how. So for example, the slash, the CSS, the error page, anyone can access them. And then anything else must be by an authenticated user. So that's one of the principles that we follow in Spring Security and in Spring Boot when you use it. Secure by default. If tomorrow I add a foo endpoint, I need to be authenticated to look at it. It's better to close things down by default rather than open them, because if you get your security wrong, you get attacks. And then the second thing we do is how can we log in? So we can log in with a username and password, and we can log in with Google. The way we enable this login with Google is we pull the appropriate starter, this one, and then we put some credentials in our application properties file in here. Please, please. Oh, look at them. They're coming. They're coming. Oh, don't look at my credentials there. Here they are, right? OK. And that's it. Cool. So if you've done Spring Security, you've seen this. It's fine. So what we wanted to be talking about is how does Spring Security achieve that? So the most important building block, the entry point where we apply security, is the filter interface. And you will find this interface everywhere in Spring Security. It's an interface to interact with basically HTTP. So it looks like this. It has one important method that's called do-filter. It takes a request, it takes a response, and it takes a filter chain, remember from earlier? And inside this do-filter method, we look at the request first, and we make a security decision. We say, ooh, this looks like an attack, I'm going to block it, or like, this looks fine, let it proceed. If it's fine, we call the rest of the filter chain. We delegate to the rest of the filters, and then ultimately to your code. And in the end, once your business logic has been processed, you can do some cleanups if you want. And so this filter chain is where the filters live. So it's a chain of responsibility, and we have these filters, which have an order, and they're executed one by one until we get to the business logic part of your code. So if you're working in a servlet environment, if you're doing just Tomcat without Spring Security, you will have a filter chain there. And you will have filters, and at the bottom, you'll have a servlet. If you're working with Spring Security, you'll have a security filter chain with only security filters. And then at the bottom, what will happen is basically your controller methods will get called. And you notice we go through them in order, but it's not a for loop. We go back out through each filter. Because the way this is set up is when a request comes in, we create an instance of this filter chain with a list of filters we're going to apply. And then we call do-filter on it. Do-filter increments the position, finds the filter at position number 1, and then calls do-filter on this filter number 1. The filter number 1 does its thing, and then calls back into the filter chain and says, filter chain, do-filter. So now we get to position 2. We call the second filter, which calls do-filter, and so on. So a stack trace of what's happening in Spring Security kind of looks like this, right? You have the filter chain, which calls into the filter 1, which calls back into the filter chain, which calls into the filter 2, calls back into the filter chain, filter 3, and so on. So that's why the stack traces are sometimes very intimidating. You have this do filter 5 bajillion times. Basically, everything below number 1 has already been executed. You don't really care about the things that happen at the bottom. When you're debugging, you want to debug the one at the very top. It's the filter that's currently running, that's currently inspecting the request and making a security decision. Okay? So, without further ado, let's make one. Let's make a filter. So in here, we're going to create a new class, and we're going to call it forbidden filter, because since this is security, we want to close things down. So this forbidden filter, is the font size all right for the back rows? Yeah, like this if it's wrong? Okay, I think it's good. Cool. So this must implement filter, and the filter we want to implement is the one from Jakarta Servlet here. If you do this, and you tell it, yeah, oops, IntelliJ, help me out, please. There we go. Implement the methods. You'll see you have 3 methods you want to implement. There's do filter, and then init and destroy. So you have to think about lifecycle. I'll give you the shortcut. Most of the filters in Spring Security actually extend once per request filter. So this is the core abstract class you want to extend from. So you don't have to think about lifecycle, where you put it, and so on. So you say implement the methods. There's one. It's called do filter internal, not do filter, but you get the idea, right? It gets a request, a response, and a filter chain. So first, we start by very small. We want to be sure that this is executed when a request comes in. So okay, let's make this forbidden because I'm French. C'est interdit. Oui. And then I want this to be executed. So how do I tell Spring Security to add this filter to the filter chain? I go into my security configuration here, and I add the filter. And you notice it reminds me that the filters have an order. So I need to decide where in the chain this goes. For a simple filter like this, it doesn't matter that much where it goes. Like, it could be very early in the chain, or it could be late. Usually, one thing you cannot get wrong is when you create a new filter, you're going to put it before authorization filter.class. Authorization filter is the filter that basically does this. And it's important to put your filters before that, because if you're authenticating a user to know what their permissions are, then they need to be authenticated before we reach this. So this, good first approximation of where you want to put your filters. Let's make sure our build runs all the time so that the app restarts when I make a change. And so now, if I do HTTP and I call 8080, right? And then I go into my logs, it does tell me c'est interdit. So the filter is executed, very fine, we can work from there. Not exactly though, right? Because if I go back to the browser and I go back to the main page on localhost 8080, I get a blank page, which is a little bit of a problem. Now, to check that you've been paying attention, what's wrong with my filter here? Why is it doing a blank page like this? Louder. We have to call into the filter chain. We have to say, yes, this is fine, the request can go through, carry on. So we do filter chain, do filter, request, response. Exactly, right? So here we're just printing and then continuing in the filter chain. So when I go back to this page, it shows up. And in my logs, which are here, it tells me c'est interdit multiple times because I have some HTML, some CSS, a favicon, and so on. Okay, so we have a filter. It's registered in the chain. Let's make it do something interesting. So we're going to take a security decision based on the request. So we can inspect, for example, the headers. So request, get header, and then we're going to look for X forbidden, right? And if this is equals to true, then we should go boom. We should say, no, I don't want this request to come through. It's a forbidden request. Let's use equals here. So how do we stop a request from happening? We're going to write to the response. We take the response object. We can set the status. Status to HTTP status, forbidden. And then we can write to the response so that the user has an idea what's going wrong. So in here, get writer, write to the response. Good. C'est interdit. And then we return. always return because we don't want to execute the rest of the code. It's a forbidden request. It looks insecure. I don't want it to touch my end user code. So I write to the response and then I return. And since I'm like playing cute with my emojis, I need to set some encoding, chart sets. This is UTF-8, cool. And then maybe a header to content type to be text plain, and maybe a char set. There we go, char set, cool. So with this, if I have a header, it should block the request. If I don't, it should be fine. Let's check this out. So in here, I make the request AT-AT, and then I put X forbidden to true, right? And it tells me nicely in a French accent, c'est interdit. If I don't set this header, and if I set that to false, for example, right, it just gives me the public page because this request is allowed. It doesn't have the X forbidden true header. Same goes for my browser, right? This browser is fine. My browser doesn't send an X forbidden header, so the request can go through. Okay, so that's our filter, custom. And it's interesting because that's exactly what Spring Security does in its own filters. So to explain this fully, I would need to explain what C-surface, a cross-site request forgery. I'm going to skip over it and then just show you the filter. But basically, let's look at a real C-surf, a real filter from Spring Security. It, as I told you, it implements once per request filter. It has the do filter internal method. And then in there, it's going to say, well, do I need to protect? If I don't need to protect, I can call the rest of the filter chain. If I need to protect against CSRF attacks, then I'm going to look the CSRF token in the incoming request, look the token in the session, match them. If they're not equal, then I want to throw an access denied. So it uses this class, which ultimately will throw a forbidden error. If the code matches, if the tokens match, then it's fine, the request can proceed. So we're doing exactly the same. With this filter that we've implemented, we do what Spring Security does. I do want to point your attention to, if you want to customize this, you need to understand how CSRF works. You need to understand what this code does. And in general, that's what happens with security. If you want to improve your Auth or customize it, and you don't understand how Auth works, then you won't be able to actually get it working. So security is complicated, and not just because of Spring Security. So we know how to make a filter. How do we discover all the filters that Spring Security gives you? The easiest thing you can do is look at your logs. By default, when the app starts, you look at the biggest log line, the one that has lots of text. And this one comes from the default security filter chain. And it tells you we will secure any request with the disable encode URL filter, the web async manager integration filter, the security context holder filter, and so on to get the list of the filters. And at the very bottom, you should see the forbidden filter here, and then the authorization filter, right? So we have the list of filters that are configured. They're configured in this class, this default security filter chain, so you can go and put a breakpoint here to see how they're wired up. That's the static configuration. If you want to learn how the filters are actually used when a request comes in, I'm going to give you the most important tip for using Spring Security that you will ever need. So in here, you're going to set the logging level of org, Spring Framework, security to trace. And here, voila, you are a security ninja. There we go. Perfect. You will be the most well-versed in Spring Security in your team. When you do this, you'll get a lot of information. So let's do the request that gets forbidden. So forbidden true. And then you have more logs than what you used to have. So let's go at the bottom. Let's unwrap. And then you can look at the logs. So we're trying to secure the / endpoint with a GET request. And so it invokes the disable encode URL filter, number 1 out of 18. Then number 2, web async manager integration filter. We see the CSRF filter here, and it's going to tell you, oh, we did not protect the request because it was the trace head getter options. And you can see all the filters that get invoked. And then at the bottom, we see invoking filter number 17, our forbidden filter. And we never go to filter number 18. So here you have a hint that something is going wrong in this filter number 17, and you can go and put your breakpoint there and not go through the misery of debugging the entire filter chain. Okay? So basically what I told you. A little recap of what we did. So we have one important interface filter. Usually you want to implement once per request filter. It takes a request, it takes a response. It reads from the request, and then it sometimes writes to the response. Sometimes it just delegates to the rest of the filter chain. The filters, they're registered in a filter chain, and the order is very important. You want your filter to be before authorization filter.class. You know, sometimes there are some subtleties and you want it a bit earlier, but a good first approximation is before authorization filter class. Okay, so now we know how to deal with HTTP requests and make a security decision such as, you know, CSRF protection, CORS, and so on. But it doesn't tell you how Spring Security logs the user in, right? When I type my username and password, or when I use Google, how am I logged in the end? So to log a user in, Spring Security is going to be creating an authentication object. An authentication is an interface. We create an instance of that interface, and it's used for two things: for authentication, so the identity of the user or the entity that's making the request. Who am I? I'm Daniel. I'm born on the 22nd of April. And then authorization. Is Daniel allowed to view that page? Well, Daniel has the role admin, so yes, they can view the admin panel. In the authorization class, this translates into two methods or two fields: the principal, which represents the identity, and the granted authorities, which represents the roles, the scopes, everything that's going to be used for authorization. If you take a quick look at the authentication object, the one from Spring Security here, to make things very confusing, it extends principal. This principal here is a Java security principal, so that's the JDK's idea of what a authenticated entity is. Don't ever use that. Always focus on the authentication from Spring Security. And then in here, you'll see, for example, get principal, which returns an object. So Spring Security is not the most type-safe library that you'll find on the market. It has a lot of instance of something something, but in 2004, that seemed like a good idea to make it extensible, and the world has been built on top of that. So you'll return principles that can be anything in Java. In this authentication object, there's a few other things. There's the isAuthenticated method. When you use it, when you say any request authenticated, isAuthenticated is going to be true all the time. There's details, usually the IP of the user that's making the request, and then credentials, the password, the certificate, whatever is used to authenticate the user. Spring Security will delete those. So the idea is that when you get into one of your controllers here, and you use this authentication object, the credentials are null. That's because the credentials are a security concern. They're not a business logic concern. We don't want you to log this authentication and then print the user's password in your logs and then ship them off to Elasticsearch or whatever. So when you use an authentication object, isAuthenticated is going to be true and the credentials are going to be null. This authentication object, we've seen in the controller, you can inject it in the controller method, and then Spring will do what's necessary so that it's available to you. But really, it's stored in a thing called a security context. So security context is the thing that's in the security context folder. It has a static method that returns a single security context, which is the context which contains ultimately the authentication object. And we've learned in university that, or when we started developing, that we should not be using global state. That's true, but this state is not truly global. This global object is only global for the current thread that's processing the request. So if you have two requests in parallel, they will have different contexts. It's not the same context for everyone. So in practice, it means you can inject the authentication like this, but you can also do security context, holder, get context, get authentication, and then you get an auth here. this auth object is exactly the same as that one, which means, if you have a library and then or an app, and then you have like 10 level of services nested calling methods very deep in a call tree, and you don't want to be passing the authentication object, well, you can grab it by doing this. And this also allows Spring Security itself to do something like pre-authorize, so do method authorization has role only for admins, right? So the way it does that is by looking up in the security context a global object. Cool. So most famous authentication object is the username password authentication token. When people start using Spring Security, they will bump into this because they do the getting started that gives them that. Do not use that for everything. It says in the name what it's for. It's for username and password authentication. If you're not doing username and password, then you do not need to use this interface. You should use, or this implementation of the authentication interface. You should use something that's more descriptive of your use case. If you actually go to the authentication interface and you look for implementations, I have tens of those. And in here, I only have form login and auth, but there's one for username, but there's also one for testing. There's one for auth 2. There's one for OpenID. There's one for when you log out. There's a lot of good implementations of this that could fit your use case, or you can even create your own. So remember a filter? We said process the request, call the filter chain, then clean up. When you're doing authentication, it kind of looks like this instead. So one, you decide whether you want to apply this filter or not. This is what we've seen with the CSRF request. If it's a get, I don't need to apply this filter. Second, you apply the filter. If it's an authentication, you're going to be creating an authentication object and putting it in the context, or rejecting the request because the credentials are wrong. 3, you invoke the rest of the filter chain. And then 4, you don't usually do 4. We do 4 in the framework. It's very rare that you need to do anything as a cleanup step. So let's do it. Let's implement a filter that does authentication. And we have to come up with a use case for that. So we have a great site. It has a public page and a private page. Now our SRE team comes to us and says, oh, I want to access the private page every night to check for XYZ. Doesn't really matter why. So they could write their own, playwright test, or something that grabs the HTML, parses it, grabs the token, makes a post request, grabs a session cookie, uses the session cookie to access the private page. That's a lot of work. So instead, we're going to provide them a mechanism to do that, which you should absolutely not do in prod, because we're going to do something very insecure, use a real protocol, but that's just an example. So we're going to do this. And so what do we implement to implement this authentication? Everyone is asleep. Wake up! What do we implement? Yeah? I heard someone. Don't be shy. All right, I'll do it. I'll give you the answer. Fine. We implement a filter, of course. So robot filter. It extends once per request filter. Implements do filter internal method. And we said, 1, decide whether we want to apply this filter. 2nd, authenticate, so check credentials. And then 3, call next. So next is easy, right? Filter chain, do filter request, response. And then 4, do nothing, because you don't need to do anything. I'm going to leave that to the side for a minute, and then we're going to start by checking the credentials. So the credentials, I'm going to pass them in a header again. So we're going to have a header called xRobotSecret, and it needs to be equal to beep boop. Very safe for your prod. So if I get a header and the secret in it is beep boop, then and if we get a header, the secret is beep boop, then we're fine. If the secret is not beep boop, we want to reject. So boom here, and then authenticate here. So boom is easy. We've done it, or at least we know how to do it. It's already in our forbidden filter. So I'm going to steal that code. There we go. And then just set a different message. Right? So we want a robot. And when we reject the request, we say, you are not Mrs. Robot. This is wrong. OK. If it's fine, if the credentials are fine, if the xRobot secret is boop, then we're going to create a new authentication object. In Spring Security, they're usually called something authentication token by convention, but you don't have to. So we're going to create one of these, create the implementation. Yeah, amazing. And so it must implement authentication. If I implement authentication directly, I have a lot of methods that I need to worry about. So we have an abstract class with some work that's already done for you called abstract authentication token. Implement the methods here. The credentials, I said they would be null, so keep them null. The principal, the only info I have about Mrs. Robot is their name, so this is Mrs. Robot. Ooh, weird IntelliJ, but fine. Cool. Oh no, my robot. Emojis are super important in your presentations. And then I need a constructor. And the constructor, this abstract class wants the roles basically of your authentication object. So we're going to say this is role robot, but I could just set it to nothing because we're not doing any authorization. And then I want to make sure that this authentication object is authenticated. So I could do set authenticated to true, which calls the method in the abstract class, or I could make this immutable by doing authenticated in here. So in is authenticated, return true. And then set authenticated here, throw new runtime exception, can touch this. Music. Can you hear MC Hammer here? Cool. So we have our first authentication implementation, and we can use it in the filter. So I have the auth, and I need to put it in the security context. So we get the security context holder. We make it create a new context, right? We value immutability, new context. In this new context, we set the authentication. And then in the security context holder, we set the new context to be the current context. So we've basically authenticated the request here. Okay, so now I should be able to access the private page with X robot secret beep boop. If I register the filter in the chain too, because otherwise it's not used. Again, robot filter, amazing. Try again, 1, 2, 1, 2, 1, 2. There we go. So this is a private page. It says this the VIP section, hello, Mrs. Robot. So now our SRE team can access this page. If they get their secret wrong and they do beep beep instead of doing beep bop, beep boop, we say you're not Mrs. Robot, and we reject the request. Little issue again. My browser doesn't send an xRobot secret header. So it tells me you're not Mrs. Robot. This is true. I am Daniel. I am not Mrs. Robot. And this is where the part about deciding whether you want to apply the filter is important. Basically, you only want to authenticate a robot when someone sends you the correct xRobot header. So in here, we're going to request get header names, then maybe write that into a collection. And so if there's a header that's xRobot robot secret, right? So if there's no header, it means it's a normal request. I don't want to authenticate. So I do the default request response. And I return because I don't want to execute the things that check for the headers. Okay? So now I should still be doing the beep boop. That works. The beep beep should reject the request. And for a browser-based authentication, which is very zoomed in, it works as normal because it doesn't check the header. Okay? So recap of this authentication object, you create that in a filter. The filter reads the request, extracts the credentials. They usually put in a domain object. They check the credentials. If the credentials are valid, we're going to create an authentication object, put in the security context. If the credentials are wrong, we're going to reject the request. And please, 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 don't slap username, password, authentication token everywhere. You probably have something that's better than this for your custom use case. So we've shown filters and authentication, and basically you can build almost all of Spring Security with this. But it's kind of very low level. filter, right? We're doing HTTP requests. And so Spring Security gives you another abstraction, the Authentication Provider. And why is it interesting? Do you remember this authentication object that I mentioned earlier? And I said, is authenticated is always true, and the credentials are always null. Then if that was true, then why would you have an is authenticated method, and why would you have credentials in there? That's because I lied. The authentication object doesn't just represent a logged in entity. It's a class that's used for two things. Yes, it's the result of a successful authentication, but it also represents an authentication request. So a bag of credentials that I want to check against a database, against check a token or something. And transforming this authentication request to a logged in user happens in an authentication manager. In the case of username password authentication token, when the login request comes in with a username and a password, the username password authentication token contains the username and the password. It doesn't know about my birth date because maybe that user doesn't even exist in the system. It goes into the authentication manager, which calls authenticate. If the username exists, if the password is right, then the authentication manager will load the user from the database and create a new username password authentication token, which this time is authenticated. And instead of having just the username, it has the user details. So my email, my my birthday, my astrological sign, and authorities, so my roles. If my password is wrong, if my account is locked, it will throw an authentication exception, and I'll get a 403 or 401, depending on your implementation. This authentication manager has multiple implementations. The one you care about is Provider Manager, which has a list of authentication providers. And this time it's called sequentially, which are specialized classes that treat one authentication type. So one for username password authentication token, one for Auth2, one for robot, one for whatever. So they take an authentication request and they produce either an authentication object, an exception, if say the password is wrong, or null if they say, I don't really know what to do with these type of authentications. So I will ignore this and I will delegate to the rest of the authentication providers that exist and let them do the security check. So let's do a use case for that. So great app, right? We have a private page, a public page. SREs can access them. So obviously, for $1 million startup, we needed a person to be the admin of this app. And we found a great guy. He's very nice, funny, beautiful hair, called Daniel. But he has a very, very, very bad memory. Daniel cannot remember his password. So what we're going to do is we're going to implement a special edge case for Daniel. Absolutely do not do this in production. When Daniel logs in, just don't check the password. It's fine, right? Just log them in. So to do this, we could do a filter. But if we do this with a filter, then we have to make sure that the request is the request that's sending the username and the password, and then look in the body of the request. Where's the username? What's the password? Split the things, extract them, so do HTTP. And Spring Security already does that for you. And here it's a good use case of using this authentication provider abstraction. Spring Security will give you a username password authentication token that has the username and the password, and then you check that. So let's do it. In here, we create a Daniel Authentication Provider, which implements Authentication Provider, which has two methods. One which tells which types, which classes it supports. So we only want to run this authentication provider when the authentication that's being checked is a username password authentication class, not when it's robot, not when it's Auth2. Okay, and then we need to check the credentials. So how do we do this? Well, we're going to get the authentication. It has a name, and when the name is equals to Daniel, right? If the name is equals to Daniel, this is Daniel, and we want to log them in. Place, fine. So I'm going to create a user object, which is the implementation of, by default, of user details. So not user details, with username, Daniel. This builder requires a password, but we're not checking it. So I'm just going to put something so that the builder object works. And then let's give them some roles, admin and user. Why not? build, and then out of this, we get a Daniel. Okay? And so we need to return an authentication object. In that case, it is username password that's coming in. So username password authentication token. And this one requires a principal, credentials, and authorities. So the principal is Daniel. The credentials, they're going to be erased. We're not checking them, so I'm going to set them to null. And the authorities, they're here. So it's like the role admin and the role user. So that's the special case for Daniel. But what about the general case? Well, I want to delegate to Spring Security, to the normal mechanism that checks the list of users and checks the password. So to delegate, what we just do is, thank you, IntelliJ. Wow, AI is absolutely amazing. We return null. Say, I don't really know what to do with a user who's not called Daniel. I'm going to delegate that to Spring Security, to the other authentication providers. So we have our provider here. We need to put it in the chain. So in the security config, authentication provider, new Daniel authentication provider. In here, the order matters much less than the filters. So basically, by default, we put the authentication providers before the Spring Security authentication provider. So your code will run before the framework code. Okay, amazing. And so our very secure app, now if I want to log in, right, I'm not cheating. Boom, hello, Daniel. And I'm logged in. However, if I log out and I try and do user and put anything, of course, it delegates to normal behavior in Spring Security, and I need the real password of the user to actually log in. So, recap of this. Authentication is the domain language of Spring Security. It represents a authentication request and the result of a successful authentication. The authentication provider is where you transform this bag of credentials into a real authentication object, and it allows you to skip, having to touch HTTP low-level stuff, parsing a body of something, and the authentication provider will leverage all of the security infrastructure of Spring Security. So if you do it in the filter, you're missing out on some things. You're missing out on observability, on events, on more security measures. And to showcase that we don't have to touch HTML, HTTP, if you imagine that tomorrow you have a new use case for logging in, but that still produces a username password authentication token, so for example, HTTP basic, then to re-implement the Daniel bit, you don't need to do anything, because the HTTP basic will extract the credentials and then present a username password authentication object to the authentication manager. So I need to save this. So now if I log in using HTTP basic private, let's make it verbose, and auth is Daniel, devox UK is so fun. Right, that's my password. Then I get hello Daniel. And the password here is not in the body of a request, and it's in this authorization header. I don't need to deal with it. Spring Security does it for me. I just check the credentials, in that case, the username. Of course, if I do a request with user, foobar, it just rejects. And if I do user with a correct password, then I get something that works. Okay? Okay, amazing, amazing. So how long do we have? 6 minutes, amazing. So why is all of this interesting? Why do you care about filters? Why do you care about authentication providers? Why do you care about authentication objects? Because all of Spring Security is built on this. And so if you want to find out how it's used, 2 things. One, which I recommend the most, is you go to Spring Security reference docs. Cool. This is a very complete documentation. And so if you have questions around, say, logging in with Auth 2, there we go. Go to Auth 2, say Auth 2 login. And then in here, it will tell you all the classes that do the configuration of this, and you'll see some filters, right? So you'll see some of the things you can configure through filters. If you don't like reading the documentation, you can find the same through the code. And how do you find this? So basically, these methods here, ultimately what they do under the hood is they create a configurer object. And this configurer object here for HTTP basic, in the Java doc, it tells you, I'm going to create a basic authentication filter for you. So you can go in there and you can read its doc or you can read its code and you'll see, oh, how does it do this? Well, it extracts, it converts the authentication by looking at the header. Oh, all right, what's this thing? Oh, basic, blah, blah, blah. Sure, it splits, it does base64, it does a bunch of things. So if I want to customize it, I can find all the setters on this thing and then change just this one bit. What if the, I don't know, what if the password is wrong? Well, I can change, I want a special method, so I can do a on successful authentication do this, on failure do that, and so go change this one object here. Same goes for, say, Auth2. So in here, Auth2 login configure. You'll see some filters, and if you look for things in here, so you remember we have Authentication Provider. You can find the authentication providers that this class or this login method uses. So we have an Auth2 login authentication provider. And if we're doing OpenID, we have an OIDC authorization code authentication provider. And so I can go look in them. How do they work? Why is my code not working? Because we're transforming the credentials here. And so now you can customize Spring Security to your liking. And then 4 minutes. Okay, take a minute to do this to appreciate the Spring security. Spring Boot does a lot of things for you. If anybody knows Auth, they'll know that just this application YAML where I set some credentials for Google, that's not enough to perform Auth, right? Where's the Auth server? Which scopes am I requesting? That's because Spring Security and Spring Boot work together to give you things with auto configuration. If you want to find the auto configuration for Spring Boot, you can look at the Spring Boot packages. And so we have a starter. You remember we have the starter Auth2, Spring Boot starter Auth2 client. This one, it's a lie. It's not the one you want. This one just pulls dependencies. The one you want is Spring Boot auto configure here. You look into this, and then there's a bunch of things that can be auto configured, including security, right? Okay. And I see Auth2. And then there's Auth2, right? Client. Okay, client. And then here, okay, reactive servlet. So we're doing MVC servlet. There's a class called auto configuration. So we go into auto configuration. And then you can see here the auto configuration classes that Spring Boot will load for you. So, we're doing client registration. And so you can see how it transforms these properties into the objects that Spring Security is doing you. So it's not magic. It's just that under the hood, this one here will have has common providers. And we know that Google is in some place. And so, if you type the magic word Google as your name of your provider, we know these things and we give it to you for free. Okay, that's a lot of content, not 3 hours. Wrap it up. Filters is how you do security for HTTP request. Take the request in, sometimes write to the response. Authentication is the domain language you're going to be working in. Authentication provider is where you validate the credentials. And if you don't want to do a custom login, I recommend using a filter with a custom authentication provider. Our robot filter doesn't do that just yet. In the repo of this, there are more steps to convert the robot filter to actually use an authentication manager and an authentication provider. With that, thank you very much. Here's the code. Here's a security attack. Scan the QR code that you don't know. I'm kidding. This is just the feedback form. Please give me feedback so I can know what I can change. If you have more feedback, grab me in the hole. If you have questions, come to me as well. Send them over the socials. And tonight, with our good friend Lore, which I don't know where he is right here, author of Spring Security in Action. We're going to be holding a Q&A open session around 6 p.m. around the Code and Coffee. So come to us, come ask your question. It's going to be fun. And with that, thank you for your attention.